Here the question says calculate the volume and number of molecules of CO2 liberated at HTP if 50 grams of CaCO3 is treated with dilute hydrochloric acid which contains 7.3 grams of dissolved HCl gas. So if what we have to calculate here is volume and number of molecules of CO2 gas liberated, and the reaction is 50 grams of calcium carbonate is treated with dilute hydrochloric acid which contains only 7.3 grams of dissolved HCl gas, right? So that is what. So now this is the reaction between calcium carbonate and hydrochloric acid. So first of all, let us write the chemical equation. CaCO3 plus HCl gives CaCl2 plus H2O plus CO2. You should know the products. If you don't know the products, you can't write the equation. But in the question, they did not give the equation, right? So you should remember whatever the equations are present in the book. This already is given in the textbook. So you should remember every equation in the textbook. So now if you balance, if you observe here, calcium, one calcium, oxygens 3, carbons 1, hydrogens 1, hydrogens 2. So let us balance first of all hydrogens. So if you make hydrogens 2, here 2 hydrogens are present, so write here 2 HCl. As we increase the hydrogens, automatically chlorines are also doubled. As chlorines are double, here check once, 2 chlorines. So fortunately balanced. So all are balanced here because we disturbed here only up to here it was correct. So here different atoms are present. We balanced hydrogens. So automatically next we have to check chlorines. Chlorines also balanced. So it is a balanced chemical equation. Now let us interpret the balanced chemical equation. So CaCO3, what is the coefficient here? 1. So that is why this is 1 mole. What is coefficient here? So it is 2 moles. What is coefficient here? 1 mole. 1 mole. 1 mole. So if we understand the chemical equation, balanced chemical equation, 1 mole of calcium carbonate requires 2 moles of hydrochloric acid. For every 1 mole of calcium carbonate, 2 moles of HCl is required. Or else for every 2 moles of HCl, 1 mole of calcium carbonate is required. And 1 mole of calcium carbonate gives 1 mole of carbon dioxide gas. And 2 moles of HCl gas gives 1 mole of CO2 gas. Why I am considering only CO2 is our question deals with CO2 gas only, not with calcium chloride and water. Right? So we have to remember 1 mole of calcium carbonate gives 1 mole of CO2 gas. 2 moles of HCl gives 1 mole of carbon dioxide gas. So if we need in moles, we use moles. Or else now let's calculate their masses. Mass of one atom of calcium is 40, carbon 12, oxygen 3 into 16. 1 calcium, 1 carbon, 3 oxygen. This 3 is for only oxygen. So 3 into 16. So this is plus 2 into. So this 2 is for HCl, not for H. If that is subscript 2 for oxygen, if it is coefficient for the molecule. So 2 into H, 1, chlorine. Remember, if you do know 35.5 not given in textbook. Gives calcium again 40. I told you just now subscript is for atom, coefficient is for molecule. So this is for subscript. So plus 2 into 35.5 plus, better you write in brackets outside U. So H2O, many times calculated until now 18 you write directly, 16 plus 2 18. So CO2 also you can remember it is 44, but for the sake we can calculate here. 12 plus 2 into 16, right? If you simplify, 40 plus 2, 52. 52 plus 48. 52 plus 16 is 48 will be 100. If you are not good at mathematics, you calculate 40 for 12, 48, you write this and add them, you get 400 units, 100 unified mass units plus 35.5 plus 1 is 36.5, 36.5 into 2, 35 to 70. 1.5 is extra there. 1.5 into 2 is 3. So nothing but totally 73 units. 35.5 into 2. 35 to 70. 0.5 into 2, 1. So 71. 71 plus 40. 70 plus 40 is 110. 110 plus 1 is 311. So 311 unified mass units plus 18 units. So 16 to 32. 32 plus 12 is 44 units. Or else you can write it as, we discussed many times, U stands for, it is one molecular, one formula unit of calcium carbonate. Only one molecule will come or one formula unit will come. So if you write unified mass units, if you mention mass in unified mass unit, that will be the mass of one molecular, one atom or one formula unit of anything. Here this is 73. U is 2 molecules of hydrogen chloride gas or hydrochloric acid, right? Like that. Instead of that, if you write grams, it will be mass of 1 mole of calcium carbonate. You know already one. It is, if you write 2, this is 1 formula unit. If you write 100 grams, this is 1 mole. 1 mole means 1 mole contains 6.023 into 10 power 20 particles. Here only 1 particle is means here. Now here 6.023 into 10 power 20 particles, right? So similarly, 73 grams, 311 grams, 18 grams, 44 grams. So interpret in the same way for everything. 44 units means it is the mass of only one carbon dioxide molecule. 44 grams means it is the mass of 1 mole of carbon dioxide gas. Nothing but it contains 6.023 into 10 power 23 molecules. This is the mass of 6.023 into 10 to the power of 23 carbon dioxide molecules mass it is. It is only mass of only 1 molecule of CO2. Remember that. Now, we have to understand the balanced chemical equation once again. For every 100 grams of calcium carbonate, you need 73 grams of HCl. It means if you take it 200 grams, this must be doubled. If you triple it, this must be tripled. Nothing but for 100 grams you need 73 grams. Isn't it? For 200 grams you need 146 grams. Right, isn't it? So in that way you have to calculate. If it is double, if it is half, it should be half. If it is 1/10, it should be 1/10. So that is what called the direct proportion. Similarly, there also you can implement the same rule. 100 grams, 44 grams. 50 grams, 22 grams. 25 grams, 11 grams. Right? So that is called the direct ratio. Nothing but here, this is according to the balanced chemical equation. Now according to the problem, we need calcium carbonate and 2 values are given. Calcium carbonate is given, HCl is given. We have to calculate CO2. Right? So let us check now. Problem. Question. As per the question. Right? As per question, 50 grams of calcium carbonate is taken, 7.3 grams of HCl is taken. So as we discussed until now, 150. If you observe, this is half. This must be half, isn't it? So if you take 50 grams of calcium carbonate, there should be half in 73, 36.5 here. 35.3 double no, here half 36.5. So 36.5 grams of HCl is required for 50 grams, but here taken only 7.3 grams of HCl is taken. Nothing but if you observe here, if you are able to 73, 7.3, it is 1/10. 1/10 of HCl is taken. Here half, it is the calcium carbonate taken half compared to this. So nothing but here we can say that HCl is present lesser than the required. Once again, for 50 grams of calcium carbonate, 36.5 grams of HCl is required, but we have 7.3 grams of HCl. That is what this is available in lesser quantity than required. So we also should know that products will be formed as long as both the reactants are present, like in this case. In this case, there are two reactants. As long as the reactants are present here, products will be formed. Once the reactants, if at least one reactant completes, reaction will stop. If reaction stops, product formation will stop. So nothing but here, as it is available in less quantity, the formation of the products will depend upon HCl, not on calcium carbonate, because in less quantity it will complete soon, so product formation will stop. So that is what we have to consider here, HCl versus CO2, not CaCO3 versus CO2. For more thing, if you observe, they may ask you some different question. Now, if you take 50 grams of calcium carbonate and 7.3 grams of hydrogen chloride gas, hydrochloric acid, after reaction, how much calcium carbonate will remain? Right? Half taken. It is half, it is 1/10. If it is 1/10, this also should be 1/10. So for 7.3 grams of HCl, you need 1/10 of 100, nothing but 10 grams of calcium carbonate is required. Here, how much taken? 50 grams. So how much will remain? 40 grams of calcium carbonate will remain. So that is not question, but we have question is related to CO2 and HCl. So whatever I have told you until now, you have read a statement. I don't write anything here, I just calculate because I don't like writing much. So you have read here, I will say once again, for 100 grams of calcium carbonate, 73 grams of HCl is required. For 50 grams of calcium carbonate, 36.5 grams of HCl is required, but 7.3 grams of HCl taken, so that is why HCl is available in less quantity than required. So that is why HCl limits the formation of the products. Nothing but here, formation of the products, amount of products formation will depend upon HCl. So HCl is called limiting reagent. So we have to consider HCl versus CO2. Let us write now HCl versus CO2. We have to calculate to know. Let us consider. Let's divide the board into two parts, HCl versus CO2. Once for volume, another time for number of particles. So volume. So we have to consider HCl versus CO2 gas. So first of all, write as per the moles. HCl, how many moles? 2 moles. This is 1 mole. Right? Remember that. So 1 mole. Now we have HCl in grams, 7.3 grams. So nothing but this is mass. We have to take here mass. Here we need volume. So consider here volume. So this is mass versus volume relationship. So mass, write HCl in mass, because once again I am repeating, as HCl is given in mass 7.3 grams, and we have to calculate volume of CO2. We consider here, right here volume, right here mass. So 2 moles of already mass, 2 moles of HCl gas mass is 73 grams. Volume, 1 mole of any gas at STP occupies 22.4 liters. Right? Now, as per the question, 7.3 grams of HCl is taken. How much? What will be the volume of the CO2 gas liberated? Let this be X. So therefore, X by direct proportion, this by this, X by 22.4 liters is equal to this by this, no, write this by this, direct proportion. Opposite to it, x opposite is 7.3, write 7.3 numerator. 7.3 grams by 73 grams. 70 grams, cut. 7.3 into 7.3 into 10 is 73. So this is ones, this is tens. 1 by 10 implies x, sorry, you read us compulsory. X is equal to 1 by 10 into 22.4 liters, nothing but 1 by 10. One decimal point to the left, 22, sorry. 2.24 liters of CO2 gas will be liberated. Now let us calculate number of molecules of CO2 gas liberated. Write the same. What is that? HCl versus CO2. 2 moles of HCl, 1 mole of CO2. 73. So why I am writing 73? I should tell you. So here we have to calculate number of molecules. So carbon dioxide should be in the term of number of molecules, and we have HCl 7.3, that's mass. So nothing but this is mass versus number of molecules relationship. So here, as we have mass 7.3 grams, so you write here 73 grams. 2 moles of HCl mass is 73 grams. So 1 mole of CO2 contains 6.023 into 10 power 23 molecules, right? Molecules. Now 7.3 grams of HCl gives how many molecules of CO2? Again, let this be x. Therefore, x by 6.023 into 10 power 23. I don't write here molecules, or else let us write molecules. 7.3 grams by 73 grams. I think it is clear for you, right? Same grams cut. 7.3 ones, tens. It is 1 by 10. Therefore, x is equal to 6.023 into 10 power 23 into 1 by 10. So I divide here 10 power 23 by 10. 1 power less. So it is 6.023 into 10 power 22 particles or molecules of CO2 gas will be liberated. Thanks for watching. If you like, help your friends.